Hi.
This is Ian.
This is Megan. Okay, so what we are doing is we built a rig that kind of examples the flashlight as the sun. As you can see, hold on, it's kind of cut out into a square, and that's because we're studying
How the square changes
how it reflects down on the board or the earth.
by different angles.
It's built so we can measure different angles. We did 3 measurements. We started with
60, and
90, 60, and 30, and we recorded them by tracing. I'll show you the first one, the 90-degree angle, which is going to be the smallest.
90 degrees.
As you can see on the same paper, it's the 60-degree as well. And then from the 60 to the 90-degree, it's this giant piece of paper.
It's stretched out a lot.
And we've recorded this data onto a graph, which I'll show you now. And basically what this is representing is how the sunlight, through the clouds or through whatever it's shining through, how it reflects down on the earth at different angles.
At a 90-degree angle, the flashlight or sun shines directly down and creates a more vivid and noticeable shape. It is more of a shape of a square, unlike at the 60-degree where it's spread out and kind of looks like a triangle. When it's at 60 degrees, it'll be colder than when it's at 90 because it's directly focused on a 90-degree, whereas 60-degree is more spread out. A 30-degree is the coldest because it's the farthest spread out. So the one temperature, instead of being in one spot, is spread out into a large open area.
If you're familiar with the tundra biome, it's commonly known that a lot of times, if you're in a tundra biome, you'll be getting a lot of sunlight, although it's extremely cold. This is because as the sunlight is reflected over the face of the earth, the heat is not really being carried, it's kind of slowing down due to the amount of energy that's hitting the earth's surface. So that's why there's a lot of sunlight yet not high temperatures. Okay, when the light's focused straight down at the 90-degree angle, you can see, I'm not sure if you can see, but from my point of view, it's a square, which means that all the light is focused and all of its energy is focused down on one point. When you change it to the 60-degree angle, at about here, the light seems to be spread out more. This is because the energy is focused down on the brightest part, which is the part closest to the light, and then it's kind of stretched over, which would mean it's stretched over the earth. As I talked about with the tundra, it's stretched around the surface. Now when you change it to the 30, its effect is even more obvious. It's because the light is, you can't see it because it's all the way out here, the light is stretched out even farther because of the light angle, and most of the energy is focused down where it's brightest, which would be closest to the light. What I'm going to explain right now is, over a long period of time, how much energy and how much heat would be focused down on one point, what that means is, over a period of time, at which angle would the most heat build up. And this is because at the 90-degree angle, it's all focused down on one, so obviously the 90-degree angle is going to be the one with the most heat over a long period of time. When you stretch it to the 60-degree angle, it's more spread out, so the heat's not going to be as focused. It's going to be more hot on one side, cold on the other. And then at the 30-degree, even more extreme, kind of warm, and then freezing cold, if that. So what I'm basically trying to put the point across is, at the 90-degree angle, with the sunlight directing straight down, it's going to acquire the most heat over a long period of time.
This experiment is compared to our natural world. The flashlight is the sun, and the surface or the papers that we use, like these ones with the shapes on them, that's like the earth. But the earth is rounded, unlike the paper that's straight out, so the energy on the paper is more focused than it would be on earth, because the earth, while it is big, it's curved. So the sun is humongous and covers like half of the earth at one time, but the tops and the poles are colder because the light shines more to the equator, and the poles they have like excess stretched out light, and the equator is hotter because it has like the direct energy and light from the sun. There's not much else. Thanks for watching.
Video was provided by Marcus and